Hello dear students, today we are going to see lecture 5 of unit 1, which is simple stresses and strain. So first of all we will see what are the content which we have to study throughout this lecture. So these are our content which we have to cover throughout this lecture. So what are our content? First one we will see bulk modulus. Second one, relation between modulus of elasticity and modulus of rigidity. Third one, relation between modulus of elasticity and bulk modulus. Fourth one, relation between E, G and K. That means modulus of elasticity, bulk modulus and modulus of rigidity. And next one is temperature or thermal stress and strain. And the next one is stress strain diagram for ductile material, and the last one we will see throughout this lecture, stress strain diagram for brittle material. So first we will start with our topic, bulk modulus. What is bulk modulus? Actually, if you will see bulk modulus, it is denoted by the letter K. It is denoted by letter K. What is bulk modulus? When a body is subjected to three mutually perpendicular stresses of same nature and intensity, that means value, then the ratio of direct stress and the corresponding volumetric strain of the body remains constant. This constant is known as bulk modulus and denoted by letter K. That means when a body is subjected to mutually perpendicular like and equal direct stresses, the ratio of direct stresses to the corresponding volumetric strain is found to be constant for a given material, and when deformation is within a certain limit, actually this ratio is known as bulk modulus and is usually denoted by letter K. And if you will see mathematically, bulk modulus is denoted by K is equal to sigma divided by EB. That means bulk modulus is equal to direct stress divided by volumetric strain. Volumetric strain means, what will be volumetric strain? EB. EB is equal to change in volume divided by original volume. And what is stress? Direct stress, sigma is equal to P by A. So bulk modulus is ratio of direct stress to the volumetric strain, that means change in volume divided by original volume, and it is denoted by the letter K. If you will see the SI unit of bulk modulus, SI unit is Newton per meter square. Once again I will repeat the main point. Actually, bulk modulus is the ratio of direct stress to the volumetric strain. Direct stress to the volumetric strain, and it is denoted by K is equal to sigma divided by EB. EB is volumetric strain. Volumetric strain means change in volume divided by original volume, and its unit is Newton per meter square. Now we will see our next slide. Next slide is relation between. Actually, already we have seen in our content, we have to see a relation between modulus of elasticity and modulus of rigidity. Understand? And relation between modulus of elasticity and bulk modulus, and relation between E, G and K. Understand? So first of all we will start with relation between modulus of elasticity and modulus of rigidity. So what is relation between modulus of elasticity and modulus of rigidity? Actually, if you will see, modulus of elasticity is denoted by letter E, or it is also known as Young's modulus, and modulus of rigidity is denoted by letter G. Understand? Or C or N. So what is the relation? E is equal to 2G into 1 plus mu. Mu is Poisson's ratio. What is Poisson's ratio? That is very important, my dear students. If you will keep everything in your mind, then only you can solve all the numerical problem. What is Poisson's ratio? Lateral strain divided by longitudinal strain or lateral strain divided by linear strain is known as Poisson's ratio. So how this relation is matching? E is equal to 2G into 1 plus mu, where E is equal to Young's modulus, G is equal to modulus of rigidity, mu is equal to Poisson's ratio. And if you will see relation between modulus of elasticity and bulk modulus, then E is equal to 3K into 1 minus 2 mu. Once again I will repeat, E is equal to 3K into 1 minus 2 mu, where E is equal to Young's modulus or modulus of elasticity, K is equal to bulk modulus, and mu is equal to Poisson's ratio. Understand? You have to keep this formula in your mind. And the third one is relation between E, G and K. That means modulus of elasticity, G means modulus of rigidity, and K means bulk modulus. If you will see relation between modulus of elasticity, modulus of rigidity and bulk modulus, then this equation will come. That means E is equal to 9 kg divided by 3K plus G. Understand? Where E is equal to Young's modulus, K is equal to bulk modulus, and G is equal to modulus of rigidity. Understand, my dear friends? So you have to remember these three formulas to solve numerical problem. Understand? Now we will see our another slide. Another slide or another topic is temperature or thermal stress and strain. Understand? Our new topic is thermal stress and strain. What is thermal stress and strain? See, there are two cases. When first one is when no restriction for expansion or contraction. जब हमारे पास कोई restriction नहीं रहेगा expansion के लिए और contraction के लिए, तब क्या होगा? When a rod undergoes changes in temperature, it tries to expand or contract in length. Understand? So no stresses are set up by it if this expansion or contraction is allowed to take place freely. Understand? Change in length, dl is equal to change in length. Understand? Thermal stress is equal to 0 here. Now we will see second case. There is restriction for expansion and contraction. So in that case what will happen? But if this expansion or contraction is prevented, stresses are developed in the material. This stress is called temperature stress or thermal stress, and the corresponding strain is called thermal strain. Understand? That means if the expansion or contraction is prevented, that means if you are not allowing the body to expand or contract, then the stress will be developed in the material, and this stress will called as temperature stress or thermal stress. Understand? So here are some formulas you have to always keep in your mind. That is Young's modulus. Young's modulus is equal to E is equal to stress by strain. These things you have to always keep in your mind. Understand, my dear friends? Strain stress diagram for ductile material. Dear students, now we are going to see a stress strain diagram for ductile material. First of all, we have to know what is ductile material. Ductile material is a material which can be converted into a wire form, which can drawn into wire. So that type of material is known as ductile material. Understand? So first of all, we will see point A, point B, point C, point D, point E, and point F. There are total 6 points in a graph. A stress versus a strain graph. Understand? For ductile material. Actually, this is a graph for a ductile material. That means a stress versus a strain diagram or stress versus strain diagram or chart for ductile material. So there are mainly 6 points: point A, point B, point C, point D, point E, and point F. Point A is equal to proportional limit, and point B is elastic limit. Point C is upper yield limit. Point D is lower yield limit. Point E is ultimate tensile stress point, and point F is breaking stress point. Understand? Now we will see each and every point in a detailed manner, or each and every dot or each and every parts in a detailed manner. Okay. First of all, first point A, proportional limit. Actually, we see from the diagram that from point O to A is a straight line, which represent that the stress is proportional to strain. Beyond point A, the curve slightly deviates from the straight line, and it is thus obvious that Hooke's law holds good up to point A, and it is known as proportional limit. That is point A. If we will see point B, that is elastic limit, it may be noted that even if the load is increased beyond point A up to the point B, the material will regain its original shape and size when the load is removed. What is elasticity? Elasticity means if we are applying any load on particular object or particular material, the particular object will deform its length, but once we will remove our load from that particular object or particular material, then that particular material will regain its original shape and size. That is called as elasticity. Same thing is happening here. Elastic limit. Elastic limit means when we are applying any loads on A to point B, the material will regain its original shape and size when the load is removed. Understand? This means the material has elastic properties up to the point B. This point is known as elastic limit. Understand? Now we will see point C, yield point. If the material is stressed beyond point B, the plastic state. What is plastic state? Permanent deformation. Understand? Plastic state means permanent deformation. Actually, plasticity is one of the property of mechanical material. In plasticity, once the object will get deformed, it cannot regain its original size. Understand? That is called as plasticity property. So same thing is happening here. If the material is stressed beyond point B, the plastic state will reach. The material will not be able to recover its original size and shape. A little consideration will show that beyond point B, the strain increases at a faster rate without any increase in stress until the point C is reached. In case of mild steel, it will be seen that a small load drops to D immediately after the yielding commences. Understand? Hence, there are two yield points C and D. The points C and D are called the upper and lower yield point respectively. The stress corresponding to yield point is known as yield point stress. Understand? This is point C. If you will see the point D, that is called as ultimate stress. At D, the specimen regains some strength, and higher values of stresses are required for higher strain. So the stress or load goes on increasing till the point E is reached. Understand? And at E, the stress which attained its maximum values is known as ultimate stress. In simple word, what is ultimate stress? Ultimate stress means maximum stress. Ultimate stress means maximum stress which a body can obtain. That is called as ultimate stress. Next we will see our point E. Understand? Next we are seeing last one, breaking stress. After the specimen has reached the ultimate stress, a neck is formed. Understand? If our material is reaching at ultimate stress, a neck is formed which decreases the cross-sectional area of a specimen. The stress is therefore reduced until the specimen breaks away at point F. The stress corresponding to point F is known as breaking stress or failure point or rupture point. One thing you have to always keep in your mind, that break, failure or rupture, all three words have same meaning. So don't get confused. Understand? So breaking stress, failure point or rupture point, all three points are same. Understand? So the stress corresponding to point F is known as breaking stress. Now we will see a stress strain diagram for brittle material. Understand? Previously we have seen a stress strain diagram for ductile material. Now we will see a stress strain diagram for brittle material. So first of all we should know what is brittle material. What is brittle material? A material is brittle if when subjected to stress it breaks with little elastic deformation and without any significant plastic deformation. That means it will break if we will give little stress only. Understand? And it has plasticity. It has plasticity property. That means it will not deform. It will break. Understand? That type of material is known as brittle material. Once again I will repeat it. What is brittle material? When it is subjected to stress, it breaks with little elastic deformation and without any significant plastic deformation. Understand? So, if you will see brittle material stress versus strain diagram, it has only 2 points. Understand? First one is proportional limit or elastic limit point, and the point B is breaking point or ultimate stress point. Understand? Once if you will put a stress, it will break. Understand? That's why. See, point up to which the value of stress and strain remain proportional. That is known as Hooke's law beyond up to this point. Understand? What is Hooke's law? Hooke's law means stress and strain will be proportional to each other. But at the point B, breaking point, or which is also known as failure point or known as fracture point or known as rupture point, all the 4 points are same. Understand? Breaking point, failure point, fracture point or rupture point. Point where the material finally breaks. It is also point of maximum ultimate stress in brittle material. That means if we put little stress in a brittle material, it will become ultimate stress in brittle material. Understand? Suppose that a material is very brittle in nature, that means if you will apply little amount of stress also, it will breaks. That's why this point is known as breaking point, failure point, fracture point or rupture point. Point 2. Understand? So this is our strain diagram for brittle material. So we have seen 2 diagrams. First one stress strain diagram for ductile material, and the second one is stress strain diagram for brittle material. Now we will summarize everything, then we will wind up. First one we have seen bulk modulus. Second one we have seen relation between modulus of elasticity and modulus of rigidity. What is modulus of elasticity? E. And modulus of rigidity? G, C or N. Then we have seen relation between modulus of elasticity and bulk modulus. Bulk modulus means K. And then we have seen relation between E, G and K. Then we have seen temperature or thermal stress and strain. And finally we have seen stress strain diagram for ductile material and stress strain diagram for brittle material. So these are the topics which we covered throughout this lecture. So dear students, you can copy the notes from PPT and study in an effective manner. Then one more thing I will tell you, if you want to go for any reference, then refer these two books. First one is Strength of Material by Dr. R.K. Bansal and second one is Mechanics of Solids by R.S. Khurmi. Understand? Okay dear students, it's good to teach you. So it is our lecture 5 from unit 1, simple stresses and strain from Mechanics of Solid. Okay students, I am Sudhir Kumar, a lecturer in Mechanical Engineering in James Polytechnic College, Aurangabad. Thank you.